Hi, in this lesson, we're going to be learning how to add and subtract with equivalent fractions, mixed fractions, and improper fractions. Our learning objective is that we're going to define equivalent fractions, improper fractions, and mixed numbers, and then we're going to practice with converting those fractions into the different types of fractions so that we can use that skill in addition and subtraction when we're working with fractions. So, just as we go throughout the lesson, it's important for you to know that you have a notes page that you're expected to complete as we go throughout the lesson. This can be found in Schoology, and you can either use the tools in Kami to help you fill in the blanks, or you can use a actual hard copy, and you can fill in the blanks as well. It's important for you to fill that in because this is going to be part of your toolkit that you can use to review for the topic test. Again, you're going to want to fill in the blanks. And anytime you see yellow on the lesson, that's a good indicator that that's a time for you to maybe pause and fill in the blanks so that you can fill in all of everything you need on your note page. So let's get started. To start, let's do a vocabulary review. Now, we've been working with fractions for the last 2 days, and it's important to kind of refresh your memory of what each term means so that when we're hearing it, we know exactly what we're talking about and we can use it efficiently. So to start, we're going to look at equivalent fractions. Equivalent fractions have the same value, even though they may look different. They are all fractions with the same amount or part. So when we look at our picture here, we see we have 4 circles that are about the same size. However, they are all cut into different amount of pieces. So on this circle here, we have 2 pieces. This second circle, we have 4 pieces, 6 pieces, and 8 pieces. In fraction circle number 1, we see that 1 piece is shaded in, or 1/2 is shaded in of the circle. And the second circle, we see 2/4 shaded in, or 2 pieces of the circle shaded in. However, when we look closely, even though we see 1 piece shaded in this circle and 2 pieces shaded in this circle, the same amount is shaded in. If we kind of take away the horizontal line and we look at both circle 1 and circle 2, the same amount is shaded. And the same thing is true for 3, 6, and 4/8. There are the same amount shaded in all 4 circles. That means that all 4 of these fractions are equal or equivalent because they all have the same amount represented in the fraction. And most commonly in 4th grade, there's another way to do this. So we don't always draw out our circles because we may be working with larger fractions. So we tend to use multiplication more so in 4th grade. So the way we do that is we multiply our numerator and our denominator by the same number to come up with a different fraction that is equivalent or equal to the original fraction. So in this example here, we have 2/3 equals 4/6 equals 8/12. And the way we do that is by multiplying. So we did 2 times 2 equals 4. And again, whatever we do on the top, we have to do at the bottom. So we also did 3 times 2 and got 6. That means that 2/3 is also equivalent to 4/6. And that's also true when we take our 4/6 and try to get to 8/12. 4 times 2 equals 8, and 6 times 2 equals 12. So that means that 4/6 is also equivalent to 8/12 as well as 2/3. And sometimes I see that 4th graders tend to get confused and thinking that they have to always start with 2. That's not necessarily the case because if we look at 2 and we try to get to 8, what can I do to get from 2 to 8? Take a second and think. And if you got multiply by 4, that would be the correct answer. And again, whatever I do at the top, I have to do at the bottom to double check to make sure that this is true. And if I do 3 times 4, I get 12. So, yep, like you thought, this is an equivalent fraction. 2/3 is equivalent to 8/12. All right, so moving on. We take I'm going to go ahead and erase our answer from the last one so we can move on to our next vocabulary word. Our next word is mixed number. A mixed number is a number that consists of a whole number and a proper fraction. So if we look at our example, we have 2 as our whole number and 1/5 as our proper fraction. And we say proper fraction because our numerator is smaller than our denominator. So those are fractions that we've been working with normally. So in your mind, you can kind of think of a proper fraction as a regular fraction. So again, one more time, a mixed number is a number that consists of a whole number and a proper fraction. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. So typically we tend to rewrite these fractions into mixed numbers or whole numbers again, so that we can revert them to being proper. In the example here, we see that 5 is greater than 2. So a bigger number or a larger number is on top of our denominator 2, which is smaller. And that makes it improper because we have a big number on top of a little number, and in your mind, you can remember that that's an improper fraction. Remember, go ahead and pause the video if you need to catch up with filling in your blanks. But let's practice trying to write this improper fraction, which we don't really like because our numerator is bigger than our denominator, into another fraction. We can also write it as 2 1/2 because we know that 2 can go into 5 2 times. So we have 2, we have 5, and 2 can go in 1 time, it can go in 2 times, and we have 1 left over. So we have 2 1/2 as our mixed number that is equivalent to 5/2. Now let's think about an example. On Friday, Mrs. Johnson decides to order personal-sized pizza for dinner and asks for the pizza to be cut in half. And she proceeds to eat half of the pizza. What fraction of the pizza did she eat? So let's just go ahead and make that an example. On Friday, she gets a pizza that's cut in half, and she eats half of that pizza. So she eats this part of the pizza. Okay. Moving on to Sunday, she eats 1/2 the pizza, and that's our written fraction. Go ahead and write that on our note page. On Sunday, she orders the same size pizza at the same restaurant. However, she wants to make it last a little bit longer, so she cuts it into 4 pieces. So now she has the same pizza, but she wants to cut it into 4ths. So now it's cut in half, and it's cut into 4ths. If she wants to eat the same amount of pizza, though, and she eats 2 slices, what fraction did she eat? You would be correct if you said 2/4. So she would eat this side of the pizza and this side of the pizza, and she would eat 2/4. Now, my lines are a little bit off because I'm trying to write on the computer, but let's say that they are the exact same size. She would have eaten the same amount of pizza because it's the same size pizza, and she would have eaten 2/4, which we know is equivalent to 1/2. So yes, she would have eaten the same amount of pizza. Now let's come up with an example let's use this example using multiplication. We just said that 1/4 is equivalent to 2/4. So let's try that with multiplication. Let's double check that with multiplication, I should say. We have 1/2 and 2/4. Let's check to see how we could have gotten there using multiplication. To get from 1 to 2, we know that we have to multiply by 2 on our numerator. And to get from 2 to 4, we would have to multiply by 2 to get our denominator. So we multiply by 2, and we got 2/4. Now the same thing can be true even with larger numbers. So I can do 1/2, and I can multiply by 16 if I wanted to. 1 times 16 for my numerator, and I would get 16. And I can do 2 times 16, and I would get 32. And I would get 32. Again, that would be an equivalent fraction to 1/2. So go ahead and pause the video and try to come up with your own examples.